Let's go back. Okay, so now that we've closed the timer switches in there, let's go ahead and highlight circuits that are active. As soon as this machine timer is turned, electricity starts to go into the machine through these contacts. The first circuit is power comes in here and feeds the motor. It goes through both the run and the start winding, and it stops here at the push to start switch. The other circuit that is energized is here. It goes through thermostats and the cutoff and feeds the heater, but it stops right here. We'll get to that switch in a moment. And then voltage comes in through the timer motor, comes out where this heater is, and then stops. So even though I drew these lines, voltage has gone from the power cord into the machine. There are no components running right now. The only way they can run is if this contact or this contact here close and allow the electricity to flow through, what we call current flow. What we have here is just voltage at that point, but if it's not flowing like a river, if it's not moving, these components aren't moving. So what is it waiting for me to do? It's waiting for me to push the start button to complete the circuit for this motor. These switches here are switches on the motor, and we'll get to that in a minute. But as soon as we push the start button and close this circuit, current can flow from here to the door switch and out to neutral. So that means I've applied 120 volts to the motor. And once the motor gets going, this here will close this switch and go out there and complete the circuit for the timer and for the heater. So now let's break down some of the components in these circuits. I'm going to go ahead and go through the motor circuit first. I'm going to erase everything else but the motor circuit. Let's start off by talking about the motor. If we look inside the motor has two windings, a main winding, also known as a run winding, and a start winding. Let's see, pause it for a second.